Hey guys, so I've been working on the fixture plate because I ran into a problem, or a potential problem. Here, let me see if I can show you. So I have these bosses here on the fixture plate, and that hole is ultimately what everything else is indexed from. So when it goes on there, the machine knows where this hole is, and it machines everything according to the location of this hole. The problem is, when you flip it like that, there's no guarantee that the actual bore is concentric to the drilled hole. At first this was kind of theoretical, but then I went and measured some of the ones that I had done like that, and sure enough, they were slightly off. So that would just kind of ruin the whole process. What I have opted to do instead is drill the bore first from the top side, then come in with an end mill and machine it so the actual bore is concentric to this drilled hole. So when you put it on the fixture plate, everything lines up. Now, the problem is the back side. The distance between this hole and this hole is very precise because we have bosses here on the fixture plate that have to line up perfectly, or else they just won't go on. So my idea was, since I'm planning on doing 6 blocks at a time, I just have 4 here to show, I'd put them across my vise like that. I'd come in, I'd drill each hole, mill it out. In fact, at some point I might switch to a reamer once I determine the exact hole size that I need. I index off of this corner, and then I come down, I drill the hole, do the mills. Then, so that takes care of the one problem. The drilled hole is concentric to the milled hole. So since I indexed off this point, and these blocks are theoretically 1 inch each, but they might be a little bit off. But that's not going to hurt anything because I'm going to take the entire chunk, flip it over like this. Then I'm going to index off of this corner, which is essentially the same corner as I indexed off before, just with a different Z height. Then I'm going to come in here and drill, spot drill, and then drill the gas tube holes. Now, when I did these 2 operations from one side, they line up just perfectly. These 2 are the ones I did the alternative method. So the bores are guaranteed concentric to the drilled hole. I flipped it over like this. I indexed off this corner, and then I went in this direction drilling those holes. So I was kind of pleased that they actually fit. They fit a little bit more snug than the other ones, so I'm kind of required to have to tap them on there with a hammer like that. Not a big deal, but that kind of tells me that this process will work to do 6 across. So the other problem was, all these blocks I squared up when I first got the mill, and the mill wasn't in tram. Since I've trammed the mill very precisely, I went back and opted to re-square the fixture plate. But all these stock blocks, I'm just going to leave them alone because they don't necessarily have to be square. Just, it makes life easier if they are. I've since trammed the mill, and I've squared up this fixture plate, and I'll show you that in a second using my dial test indicator. These blocks I'm not worried about right now. I just mainly wanted to get this fixture plate square, and I didn't film it, but it was across this distance, it was significantly out. But so far so good. They fit. And I think that this process is going to work. Little socket head cap screws in there. Screw them down. I'll probably use an impact driver or something in production. But once you get them down, they're extraordinarily rigid. The other option I toyed around with was milling off this boss for the gas tube, these little ones, and then putting a Mighty Bite clamp on the top to clamp the top, not to really clamp it, but just to make sure that this block is relatively square. Because even though I have some margin of error designed in the size of the block on all sides, if it's significantly out, it's just going to lead to problems. So I need to tackle all these problems first before I start getting too far along, and then I realize, hey, I got to go back and redesign my whole process. So this thing feels like it's all a solid piece of steel. Then I want to be able to flip it and clamp it in the vise and do the light machining on the top for the recoil grooves for the Picatinny rail. Then flip it around the other way and I can't remember what happens here, either some bayonet lug machining, but definitely the little socket for the quick detached sling swivel. Then I'm going to make another fixture that holds them horizontally so I can get the side milling done. But this is what I got so far. So the real test is once I have 6 actual squared blocks, then I don't really want to go back and square the ones I have. I'm just going to order some more bar stock like this, cut it up, square them just like I did with these, except they'll actually be square this time, and then try the whole process on 6 of them. So I'll take 6 of them, I'll stack them together, I'll put a C-clamp on the outside just to keep them, you know, oriented amongst themselves properly so they're nice and tight. Index off one corner, drill all the holes, mill them out, flip them around, index the X on essentially the same corner, and then come back and do the gas tube holes. Theoretically, they should all work and line up perfectly. I was very apprehensive about doing it this way just because so much depends on the location of these 2 holes and the relationship they have to each other, and if they're off, this thing just won't fit on the fixture plate. I really don't like that idea, but if I can pull this off and get it to work, it should work out really nicely. I wanted to show off some of the drills that I've been using, because drilling things on the mill is so much quieter and peaceful than milling them most of the time. So this is my 1/2-inch spot drill, this is a 1/2-inch carbide drill, this is a 1/2-inch cobalt drill. This is a 14mm high-speed steel drill, and pretty much these are the only ones I use. I played around with using the bigger ones. This is a 17mm maybe high-speed steel, and this is a 19mm high-speed steel. These 2 drills are obviously of the same manufacturer, you can just tell. This one is different and has a much finer finish on it, and this one works great. All these work great. These 2 are absolute shit. The edges melt or something, they roll over, like the corners just disintegrate, like right when you start cutting. The edges just round over and roll over. It's like they're made out of aluminum or something. Anyway, these suck, so I don't even use them. I played around with using them just because they were large diameter. It saved some milling time, but I don't use them at all. These, on the other hand, work great, especially the carbide drill. I've been using this one a long time, and I only had to sharpen it once because I chipped it by accident. This one I just started using just because I needed a longer drill, and this is just a cobalt drill I got from Harbor Freight, and it works great. This one works great too. They all work great except these two.
Alright, sorry for all the talking. Let's get to machining. Here I am spotting the blocks again, and this drilling operation was a bit too aggressive, 4 inches a minute. That's a 1/2 inch cobalt drill. It wasn't aggressive at all for the motor, but you can actually hear the Z-axis motor skip some steps here and there, and I ended up pausing it, and then I went and checked the Z0, and sure enough it had skipped steps, so I backed it off to 2.4 inches a minute here. I increased the peck depth to 0.1, and that worked a lot better. So you're probably wondering why I'm doing it from the back again. Well, this is one of the ideas I came up with, was doing it just like before, except drilling the hole undersized to 1/2 inch instead of the 14 millimeter. And my idea was, after drilling it, then flip it over and machine the bore. And then once the main bore is machined with the same end mill, go down and machine out that hole to the 14 millimeter size. This ended up being probably also a bad idea, only because I machined it out a little bit undersized and it didn't fit on the fixture plate, but also because when you do that, now the relationship between the gas tube and the main hole may not be exactly right anymore. So this is a process that I ended up abandoning, but it's a machining video, so we'll watch it anyway. The gas tube drilling is the same. I'm pretty happy with that cut. I don't feel like I'm going to break off the drill like before. Okay, so then I thought, well, maybe I'll try, instead of roughing out the main bore with a roughing end mill, I might try a big drill. And this didn't really work because that drill just couldn't hold its edge. The motor kept up fine. It's just that the edge of the drill just wouldn't make the cut, and it just chattered really bad. So I'm back here to roughing it out with an end mill, which I think will be ultimately more accurate anyway. Drills tend to walk and such. And it definitely did, because that drill is 19 millimeter or 0.748 inches in diameter, and I'm roughing out to 0.749 right there, and you can see that drill took much more of a significant cut than that, because there ended up being a kind of a oversized bore at the very top. So I knew that wouldn't have worked. Definitely have to go down another couple of sizes in drill diameter. So here I am roughing it out. This is kind of a modified roughing operation. I increased the depth, I doubled the depth, and I'm sorry, this is the finishing pass. That previous roughing operation, I doubled the depth, and I had reduced the width of cut by about 5%. And it just sounded better, so I went with it. This is the finishing cut. I actually doubled the depth on the finish as well, but I ultimately ended up not being happy with the finish. Here it is boring out that drilled hole to 14 millimeter. There was a lot of chatter involved in that, so I didn't like that cut at all. So here is the actual process that I think I'm going to use. I'm starting from the front now, and this is back to the 14mm drill. I've made it a bit more aggressive. I doubled the peck depth, and I've kind of sped up the RPM a little bit. I'm not concerned at all about stalling the motor. The only thing I'm concerned about now is stalling the Z-axis on the way down. I almost couldn't believe that using that 1/2" drill at 4 inches a minute actually skip steps on the Z-axis, because we're dealing with a lot of weight with the motor and the spindle head and all that stuff. And the Z-axis motor still couldn't pull it down hard enough into the material. So that's my only concern, and I'm listening here, and I didn't hear any skip steps here, and I actually checked the Z height after it was done, and I didn't skip any steps. So this is a nice medium aggressive cut. We're back to the same roughing operation here, where you can see I have a 0.2 inch depth of cut now and a 10% step over. That just sounded better to me than the 15% step over at a 0.1 depth of cut. It's almost like the deeper the cut, the better it stabilizes. But you can see here, it's not clamping that block tight enough in the vise. It's kind of wobbling, and I got that thing cranked down hard. So I went ahead and finished this bore after I'd kind of tightened it even more. And when it switches to the next bore, it starts that rocking again. So I've got that vise about as tight as I can get it. So what I did was I just grabbed a shorter parallel, so there's more vise purchase on the block, and I clamped it down hard again, and that seemed to do the trick. And I'm back to the 0.05 depth of cut over the 0.1. I wasn't happy with the finish on the 0.1, so I went back to 0.05. That leaves a pretty nice finish. Eventually, I'd like to do this with a reamer. Maybe the boring head, but I just can't seem to get a good finish with it. Probably a reamer is the best way to go. Here I am, flipped the part over. I've indexed from that other corner, and this is the same drilling operation. So now the main bore and that hole is concentric to each other. The only issue now are those gas tube holes in the right orientation. They're not really the right orientation, but the right position to that drilled hole. And I also had problems, like I talked about before, with this fixture not being square. So I went ahead and squared that up now that the machine is properly trained. Probably wondering why it's going so slow, and I was too. I was using the numbers from G-Wizard, but it turns out I had made 2 tools in my G-Wizard tool crib. Both of them were the same face mill, but one was with 6 inserts in it, one was with 1 insert in it when I was fly cutting on those titanium dies. I guess I just wasn't paying attention, and I selected the 1 insert face mill, so this is the speed and feed for a 1 insert face mill. I was kind of wondering why I was going so slow, and even the surface finish wasn't all that great. It was actually better when it was going faster. But here's an issue that I ran into. The overhang on the vise, that bar kind of dips downwards. And my original idea was, well, okay, it's it's not being held properly by the vise, so it's kind of deflecting down. And you can see that clearly here when I run the Heimer across. It's deflecting down about a couple of thousandths there, I guess. Maybe 1.5 thousandths. So my idea was to put a bolt there and then kind of back out the nut until it was level. And it took me a while to get it just right. But I got it to where it was level right across. And then I did the cut. And part of me was thinking maybe this unsupported area of the bar is just not, since it's unsupported, it's being deflected downward when the tool is cutting. Or it could be, well, I originally thought it was being deflected downward. Actually, after I got this all pretty much leveled, I made this cut and I checked it on the surface plate with the dial test indicator, and it basically doubled the error, or it doubled the amount of deflection. So that made me think, okay, it wasn't deflecting downwards, it's deflecting upward, and I just made it worse. And it makes sense because those cutters are coming in at such an angle to where they would actually pull the bar of material up into the cutter instead of holding it down tightly. So what I guess I should have done is break out the other vise or clamp something on there to hold the bar down to prevent it from deflecting upward. But I did the cut again without pushing the bar up with that bolt, and I just did it very lightly, and I'm pretty satisfied with those results. So you can see here with my dial test indicator, zeroing it out at one end and running it all the way across to the other end. It's only off by about 1/1000th, and that really only comes into play on that unsupported area of the bar, and that's where it was deflecting upward into the cutter, so it took a 1/1000th deeper cut than it should have. I'm not too concerned about that. So when I measure this side, where there's a lot more material in the z-axis direction, the likelihood of deflection up or down is greatly minimized. So you can see that needle doesn't even move across the entire 12-inch length of that bar. So that tells me a couple of things. One, it's definitely deflection happening with the metal bar and not any kind of machine error. And two, that my machine is pretty well squared and trammed to have virtually no perceptible error over 12 inches. So I also measured the squareness in the Y direction here, because that was definitely way off before I re-squared it. And even though, I mean, that surface finish looks sort of rough, it's not that bad, but it's rougher than it should be because I machined that when the machine was out of tram. I'm sure you can already tell that this is going to be a much more involved series than the dice. Here's a little preview image from the upcoming video where I actually get to put the fixture plate to use. Again, thanks to all the new subscribers. If you're not a subscriber, please subscribe, like, share my videos. You can also read more about this gas block and other things at www.warmachinellc.com. You can also go and like us on Facebook. Thanks, and see you next video.